Hi, I'm RJ Straighton, and this is my final video presentation for the CPU scheduling project for my operating systems class. So as you can see, I am set up in my virtual environment right now. This is still the same one from last time. It's just Ubuntu Linux using VMware Workstation. I am already in the directory where my project is currently stored. As you can see, it got a little convoluted with the directories. I think that happened when I was doing the git clone, but whatever. Let's just go ahead and type .NET run. And this might take a few seconds. Nice, okay. So, bringing up a menu. So if we selected 1 or 2, that would allow user input. They can choose the arrival time and burst time, and also how many processes they want. And it will, give you the results of that. For the sake of this video, I'm just going to go ahead and do test values. So this is already taking in stuff I've already made. It's taking in the same thing for 3 and 4, and I will show that, and it's also in my report. So let's go ahead and take a look at 3. And that was really fast, and that's because this is just simulating, the scheduling algorithm. We can see the completion time, the wait time, and the turnaround time for each process using shortest remaining time first. So now let's look at multi-level feedback queue. If we scroll up, we can see which process is running, which queue it is in, and the current burst time. So the time slice for multi-level feedback queue is currently 4 seconds. So process 1 with a burst time of 8 will not actually finish completing. So then if we track this down here, process 1 from Q1, so because it didn't finish, it got bumped down to a lower priority queue, and this time it has 4 seconds, and then after that it'll complete. You can see that process 5 makes it all the way down to Q3 because there are 4 levels of queues, 0 through 3, and you can see that process 5 had quite a long burst time, which you can also see the completion time at 47. Now, something interesting that happened, I think because process 5 had such a long burst time and a bit of a delayed arrival time, is that the throughput right here for multi-level feedback queue is actually the same as the throughput for shortest remaining time first. Obviously, they have the same number of processes, but it's interesting that they finish at the same time. Again, I think it's because of process 5, but I could definitely be wrong. So let's go ahead and exit, and I will show, so here are the test values that those methods are taking in. So process 1, arrival time, it's just ID, and then arrival time and burst time. And then if we wanted to go back here and do .NET run, I can just kind of quickly show taking in user input for 1 or 2. I have the algorithms more thoroughly explained in my report. But let's just go ahead. Let's say we want to enter 3. I want 0, 8, then I want 1, 4, and I want 2, and 10. And yeah, that's pretty much it. Thank you for watching.